Professor Richard Dawid, who started out as a theoretical physicist, PhD at the University of Vienna, after which he continued in physics for a while, but eventually switched to philosophy. Now professor of philosophy of science at the University of Stockholm. And he's probably most famous or infamous for his framework of non-empirical theory confirmation. For instance, his book on string theory and the scientific method with CUP. But the framework is very versatile and also applicable in other contexts, such as inflation. So I'm looking forward to your talk.
Thank you very much. Yes, meta-empirical assessment will play a role here as well, but in a different way than it's empirical. So what I want to talk about today is the general question of having credence or having trust in cosmic inflation, and thinking about a little bit about reasons for having trust. And the entry point I want to choose is this debate that happened a few years ago between Steinhardt and first Niels Nakamura, and then a very large group of inflation physicists who responded to what they were saying. So I think I can be very brief about introducing inflation, because a lot has been said about inflation already. What I want to flag once again is that there is empirical evidence at various levels that support or consistent with the hypothesis of inflation, and this plays out at various levels. First, at the level that provided the motivation to develop inflation in the first place, but then also at the level of decision data that has been collected more recently. So there is this set of empirical support. However, after Planck, or initially related to Planck and then after Planck, Steiner and Löw argued that inflation is in serious trouble. So what they claimed is that the simpler approaches of inflation are next to ruled out by the data. You need a lot of fine-tuning to reckon. And the more recent understanding of inflation that can account for this, and that was then pointed at in particular also by the first responses from Dawid and Nakamura, they don't amount to a scientifically tested theory. So there was this back and forth. Claims have been quite forcefully rejected by exponents of inflation. And the question I want to address here is whether there is a philosophical perspective on this theory that kind of makes it more interesting than what one might see at first glance, and whether there is something that we can learn about the status of inflation from that debate. So let's have a slightly more detailed look at what ILS are saying. Initially, their initial paper did not make this distinction they later introduced between classic inflation and what they call postmodern inflation. But they just basically made the point that on their understanding of inflation, inflation has a fine-tuning problem, and they were focusing on single-field level inflation. So what they argue at this first stage is they argue within a fairly narrow context of understanding inflation. And then the response was first, Google Nakamura questioned those fine-tuning arguments, but then this debate, specific debate, is of less interest from our philosophical perspective. And second, they actually agreed with INS that nowadays one maybe should specify significantly this level of inflation anyway. So one should have this broader perspective that considers multi-field inflation, and there may be conceptual reasons at a theoretical level that favors multi-field inflation anyway. So one has this wide spectrum of flexibility, and what empirical testing of inflation now is about is basically testing models and ruling out models and understanding which kind of models are still alive and which can be rejected based on the empirical data. The second level that we won't go into any detail and that won't play a big role for us, but I think it makes sense to mention it also, is the ILS rejection of the multiverse scenario, which kind of plays out in a similar way. So they argue that once you enter these multiverse discussions, there is no stable concept of what it actually means to assess probabilistically those scenarios, because there is no stable understanding of the measure you want to apply. So therefore, they argue that this destroys empirical testing as a method of falsification from the start, as the measure has to be chosen from the start in order to seriously allow for falsification. Against this, once again, Booth et al. Argue that it is actually legitimate to learn about the method from the physical process. So one may not yet fully understand these issues, but once again, collecting data, understanding how theory, models, and data are related to each other, that is a constructive process towards also understanding, have a better grasp and better understanding of the measured issue. So that is the back and forth about those issues. And in a nutshell, the INS conclusion is that classical inflation, as they view it, that's significant overall inflation, was scientific as long as it only considered those simple models. So that is a serious scientific theory on their understanding, but they think that this is not consistent with the data anymore. And opposed to this, they construct this notion of postmodern inflation that allows arbitrarily complex models, lots of different things and parameters, and that also involves a multiverse. And they claim that is not a critical theory because it's not falsifiable. And therefore, it's not scientific. And Booth et al., in response, say that it already justifies calling inflation scientific, that you can test models. So already the fact that there are testable models that can be developed on the basis of inflationary theory safeguards that this is a scientific and generally sound scientific process. And they also emphasize that accommodation and the limit-limited reasoning that plays out in the context of this model testing are standard elements of science. So there is nothing wrong with that. And it can make physicists, help physicists learn more about the paradigm of inflation. And also at the level of multiverse, data can provide indications of what we are measuring with respect to multiverse. Then there is also one aspect in the response saying that there it's not that every around the next corner one always needs to stretch a lot in order to find any models, but they come from the data, but there is a sense that generic class of models are being confirmed. So it's not just an accommodation let's say in a defensive sense, but one gets reinforcement of the paradigm on that basis. So one response that ILS would have to this genericity that is kind of important is that they would point at the situation that actually there, on the other hand, on one hand, there is genericity that survives, but on the other hand, there are most simple models that are actually ruled out. So there is it's kind of a changing notion of genericity in view of the evidence. So what they say, it's not clear. You cannot translate this observation that there is some level of genericity preserved in confrontation with the models. You cannot really translate that into prediction of inflection, because whenever some scenarios, some sets of models that would have seemed likely at some stage get ruled out, then okay, and you say, okay, we learned something. I mean, the way Booth and Al understand this would be that we learned something from ruling out those models. The way ILS represented is that this means, however, that there are no actual predictions, and therefore there is no probability. So, having staked out the debate, the next question is, so what is the philosophical background of the debate? And that is a meaningful question in this particular case, because it's clear that ILS do have some philosophical background on which they build their discussion. So it's clear that they were aware of philosophical concepts when developing. So it is not just discussing the physics, but they discuss the physics having some philosophical structures in mind in the back of them. And one can see that in a crucial paragraph they introduce when they characterize their understanding of scientific testing. So what they say is, in testing the validity of any scientific paradigm, the criterion is whether measurements agree with what is expected given the paradigm. In the case of inflationary cosmology, this test can be divided into two questions, and that's the crucial point now. A, are the observations what is expected given the inflation potential X? And B, is the inflation potential X that fits the data what is expected according to the internal logic of the paradigm? In order to pass both questions, must be answered in the affirmative. So that's what they put up as a criterion for endorsing inflation. And this represents a specific, though extended philosophical perspective on the issue. It is a likelihoodist view. So it characterizes endorsement in terms of the probability of the evidence, even hypothesis or the model. But it's not a straightforward likelihoodist view. It's an extended likelihoodist view that brings into the picture also the probability of the model given the hypothesis. And that's, of course, the crucial issue, and that's what they will work with in the end. They cannot, and they do not want to deny that there is a way of developing models and of testing models, which would be the probability of evidence given a model. That's the first part. So they don't criticize that. What they criticize is that this part, the second part, doesn't work for inflation. And now we need to point out at this stage already that this it's an interesting position they have here. Because normally if you if you adhere to this likelihoodist perspective, you do it because you don't want to be a Bayesian, so you don't want to talk about probabilities of the hypothesis, and you want to be kind of strictly empiricist. So you don't want to say more than you can based on strict empiricism grounds. Now, in adding this, they in an interesting way deviate from that. So they want to be strictly empiricists, but they are not in a way. And that's the philosophical the core of their disagreement with Guth and al. Because Guth and al, to the contrary, in their response, endorse a straightforward empiricist view. So they say the testability of models suffices to make the process scientific. So they just point at this, right? They say, but we have this, and that's enough. So what more do you want? And the difference between them then boils down to the question at the level of their discussion, whether ILS have any reason why they want to add this criteria. Now, at this stage, the way one would understand this, the situation would be basically in terms of different perspectives or different expectations with respect to the research problem. So what ILS can answer, or what is suggested by their view as they present it, is actually they prefer a fairly rigid traditional view in theory testing, right? So they want to have this going up all the way to the hypothesis, and they want to have a fully spelled out theory age at each stage of empirical testing. And they want to then have a clear understanding of what empirical testing amounts to, and then you confirm or reject. And that they argue needs to happen at the level of theory rather than at the level of model. And they don't really explain why, right? They don't have a concept why they do that. It just looks like emphasizing that inflation should more look like the conventional process where this actually happens in other scientific fields where there is not this. While Guth and al's view, if you want to frame it at the level of models, of the theory rather than model, would allow for a more fluid conception of the theory or the framework, let's say, of inflation. So it would say we may have shifting understanding of what the theory of inflation actually amounts to. We may, for example, with respect to the measure problem, with respect to multiverse, we may also have even different understanding of what empirical testing amounts to in a given context. And then we have this constant influx of empirical data, and at the level of theory, there is just this interaction. And all that is fine, they would argue, as long as at the level of models, I have something akin to this. So they say at the level of models, we of course need that. We need clear prediction. But at the level of theory, we don't. And given the fact that there is a huge spectrum of models, and we cannot rule out this paradigm easily based on ruling out specific models, that's not a problem, as long as testing model and surviving and rejecting models gives us progress. That would be their understanding. So one might say, okay, yes, so this reflects the new situation of fundamental physics. It is just the way it is. And what ILS on that account just represent is wishful thinking about the scientific process with respect to inflation should look more similar to the way a scientific process looks in other contexts. So this is not, if one accepts, therefore, ILS's own likelihoodist perspective, they don't seem to have a fundamental point. they do point at some insufficiency of the current understanding of inflation, and there may be some debates on the specificities of that, whether they're right in some cases or not right in some others, but they don't seem to have a fundamental point that justifies their very strong claim that there is a problem of scientificality back to inflationary research. Now, what I want to argue for in the following, however, is that it's possible to reframe this discussion in an instructive way that makes it more interesting. And that is by representing the gist of their analysis, of the ILS analysis, in a probabilistic Bayesian framework, which is explicitly not what they want to do, right? It is not representing differently what they actually want to say. It's just saying once you add this, it makes what they are thinking actually much more interesting. And I will give a reason why this doesn't seem entirely implausible. It is, to some extent, of course, arguing their argument against them. But on the other hand, there is a point why the reason why this looks looks not entirely unnatural, let's say. So if we once again think about the way ILS argue, then on the one hand, it's clear that they follow these empiricist and falsificationist ideas. And they, as we already mentioned, it's not clear on that basis why they are not satisfied with testing models. Their account would actually suggest that they should be. And one natural response to that is to say they are not justified with testing models because they have the feeling that testing models does not help us endorsing the theory, right? There are so many models, even so many models that agree with the data at each state, presumably at each state in the foreseeable future, that we cannot endorse a specific model based on testing, and we cannot endorse a specific theory or the theory of inflation based on that testing either, because the spectrum of models is so flexible. However, if one wants to make sense of that point, if one wants to make that point explicit, one needs to think in terms of probabilities of theories and models. But what they actually seem to think is, actually, there is no way of having a significant credence in a theory or a model based on this. So if you don't have a credence in a model, what is in the end the point of testing models as long as you cannot generate credence in the theory on that basis? That would be the reading of what they actually think in the background. And then they say, well, you can't do that either, right? Because there is this other issue. There's this issue of abundance of models. So finding models that agree with the data does not confirm the theory, because the theory as it stands is not falsifiable. So they want to argue within the falsifications framework, but they've always revealed that they implicitly think in terms of credence. That is the claim. Now, if we move on to the other side, Booth and Al's response also focuses on an empiricist perspective. So they focus on the testability of models, and rightly so, because that's what ILS give them. And their argument to ILS and that is at that basis, and that it is completely, it is a powerful and sufficient argument against them. The argument is empiricist, and it refrains from any allusions to credence in theories either. Now, however, it is clear that the current status of the theory of inflation, is viewed by its exponents, or many of its exponents, to be far above just meeting the scientificality principle of testability of models, right? And I mean, we heard one expression of that position earlier today. So inflation is considered an element of standard cosmology, and it is understood that there are substantial reasons for having trust in its viability. And I wanted just to give you one one quote by Andre Linde that very clearly expressed it well. So it is clear that what they do in their response does not fully reflect their attitude, or many cosmologists' attitude to inflation. And the reason is that they want to be on the safe side, so to say, and they don't need to do more in order to respond to ILS, because ILS themselves don't address grievances. So what happened is that in this debate, both sides want to appear strictly empiricists, and therefore refrain from allusions to credence in theory or models. But on both sides, thinking in terms of credences is in the back of their minds. And that's why the debate happens at all. And once one accounts for that aspect, the debate becomes substantially more interesting. So the more interesting aspect then is not about scientificality, which is just an overblown lack of scientificality, is an overblown claim by ILS, but about prospects of having credence in the theory of inflation. And of course, the question of having credence in the theory of inflation is a very relevant question, given the dominant position, the paradigm nowadays. So if one says, well, if one had the understanding, actually, once the theory gets testable seriously, chances are maybe 99% that this is wrong anyway. That would not be a very fortunate perspective, given the huge amount of research and work that enters the project. Because you might say, it happens in physics all the time that people work on theories that don't end up being viable. But in this particular case, and given the enormous focus on inflationary research, it would be unfortunate to have such an outcome. So it is relevant that that's not the general understanding among inflationist physicists. So if I frame the debate now in terms of credence, what ILS say is that testing an inflationary model does not generate significant credence in that model, just because there are too many of them. And it does not generate credence in the theory either, because model building is too flexible for extracting general prediction from the theory. So there is this very flexible paradigm, and this creates this option. Therefore, they argue the research context does not sufficiently change credence, which renders it scientifically questionable. That would be their criticism if understood in terms of credence. But that would be what their criticism turns into if one changes their argument to an argument about credence. Now, if that was the argument, Husserl needed to respond to this credence-based version of ILS by pointing at actual reasons for trust in inflation. Reasons that are not covered by what they argue, not covered by this straightforward scheme. And now it's clear that inflationary cosmologists, as we've said, do have trust in the theory, but how can they defend that trust against ILS argument, let's say in Bayesian terms? That's now a question, and that I suggest is an interesting question. It's a philosophically relevant question how to do it. And this brings me to meta-empirical confirmation or meta-empirical assessment. And I don't have time to go into any details about this. What I just want to give you in a nutshell, the basic idea about this. So the idea is that once we want to represent empirical confirmation as an issue of having trust in a theory's prediction, so having trust in the viability of a theory in the sense that the predictions within a certain domain are considered likely to be or probable to be correct once tested. If we want to have that, it seems necessary to introduce two elements, two components of confirmation. On the one hand, there is agreement between the data and the theory's prediction. That is, of course, the canonical part. And this establishes the theory's viability with regard to those specific empirical contexts where the testing has happened. And then there is the second meta-empirical assessment part that generates credence in the theory's general viability within some empirical horizon. And we come to that, how we can do that. So the point I don't want to write down the Bayesian structure of this, because I don't want to go into this Bayesian formalism, but the point, which in the context of the Bayesian formula, is that you need total probability of the evidence in order to express updating. And if you state the total probability of the evidence, you sum overall theories you know times the probability of the evidence given those theories, plus unconsidered alternatives. And as long as you don't say anything about those unconsidered alternatives, you don't have a total probability formula. So normally you cover that with this so-called catch-all hypothesis. I don't think I attribute some reasonably low probability to catch-all something whatsoever to the probability of the evidence given the catch-all. So I don't know much about this, but I try to keep it small. If I do that, then I get updating. So I get increase of credence based on updating on this evidence. Now the point is that formally that's just not enough, right? If I had a couple of alternative theories that I'm not aware of, and that actually also make those predictions, that ruins my credence generation. Right? So I'm completely off with respect to my assessment of credence, because I thought there are none, but now it turns out there are some. So the significance of the empirical data is much lower than that, and one needs to assess that. And one needs to assess that based on something, on some observations about the scientific process, let's say. And the important point is that to have trust in a theory, I need also that. I need 1 and 2 normally. And interestingly, and that's a tangent, you might skip 1 to some extent, and that would bring you towards some string theory, but you must not skip 2. You always need number 2. So the confirmation value of empirical data is determined by these 2. And that's a general observation about the research process, the general observation about confirmation that has nothing to do with inflation whatsoever. Now, the way this looks, if you want to draw a picture, is that the simple view of empirical confirmation would be that one. Empirical confirmation is just about theory that predicts data, and then we get some confirmation. So that would be the arrow in that direction. But the point is, this arrow actually never works. It does not, on its own, this does not work. And what ILS do, what they base their analysis on, if you translate what they are doing into let's say half Bayesian count, is that they think in terms of this, right? They point at this and say, look, you don't get this in the context of inflation. But the point is you never get this. And in many other cases, you don't get it either, but it's not a big issue because these assessments, if you have very strong empirical confirmation, these assessments are not all that important. Everyone takes them for granted. Everyone takes them against it for granted that if you have a theory that very specifically predicts a certain value of a parameter, and then you test it and you say, yes, exactly that's what it is, you assume naturally, sure, and then probably it's very unlikely that any other theory can do that. So I should have considerable trust in that hypothesis. In the context of inflation, where there is no such specific model that just this model exactly represents everything that all the data that has been collected. The situation is more complicated, and it's much less clear whether I should trust the theory in light of that evidence. And it's obvious that, or it's more obvious, or that's what ILS point at, that this story on its own is not sufficient. So I need to go to a more complicated story, and that's the MAA story, where the theory predicts empirical data. And then I can ask the question whether, informed by this empirical context, let's say, I can find observations about the research process that suggest that the number of possible alternatives to that given theory is small. Maybe there are no other ways of doing that, of agreeing with that empirical data. I have this, the structure of this connection is also aligned with this structure. So I need to look for observations that are kind of predicted by the hypothesis that there are no alternatives, there are very few alternatives to that theory. And then I kind of have mid-empirical confirmation of that hypothesis about constraints to the number of alternatives that the method. And if I infer, okay, probably there are no other theories than the one I have that manage to be in agreement with the data, then this increases the probability of the hypothesis. So that would be the full structure of confirmation anywhere where confirmation happens. And that would also be the full structure in the context of inflation. And now the important point is that if I understand confirmation or increase of credence along those lines, the point that there is just one model, the point that that this on its own already looks as if it will generate confirmation, is not as crucial. And it's not as crucial. Well, I need to say a little bit about unexpected mid-empirical assessment before I come to this next point. So I will return to why this is not that crucial. But for the time being, just let me explain those three arguments. One is a no alternatives argument. One of those observations, F, that I have back there, is the observation that scientists haven't found an alternative theory. The other observation would be that in other comparable cases, theories that were identified on that basis and are assigned to that are supported by an alternatives argument were empirically successful later on. And then there is the unexpected explanation argument. That's the observation that to explain something without having been developed to that end. In an empirical context, that would, for example, be a novel confirmation. So the theory was not developed in order to account for that data, but that would agree with actually that data. So, okay, so having those three arguments, it is clear that this works much better for generating credence for inflation because it works at the level of theory. The problem for empirical confirmation in this simpler picture was that testing only reached up to the level of models, but then there was no connection from confirming a model or model agreeing with the data to generating credence in the hypothesis. But here, mid-empirical assessment works at the theory level. So if I develop an alternatives argument, the alternatives argument obviously is not at the level of models, right? There are lots of models. An alternatives argument, to the extent it can be developed, plays out at the theory level. Claim is, someone thinks that there are no plausible theories that can explain what inflation can explain. And there is a basis for expecting that none of those would come up either. So basis for the inference that given that we haven't found any, or given that physicists haven't found any, maybe there are, or probably there are, or if there are any, then very few. Maybe just one or whatever. So that's plays out at the level of theory. So that is about credence at the theory level, not credence at the model level. Which means that MEA can support confirmation at the theory level, even though there is no significant credence in any of the models that have been tested. The mere fact that there is a model at this stage that agrees with the empirical evidence suffices, because that can be the basis for saying this paradigm, this theory, offers an explanation based on these sets of models. And we don't think that any other theory does. And that generates theory. The second part, in conjunction with the observation that there are successful models within the inflationary paradigm, can generate significant credence in the hypothesis. And on that basis also, more stringent data can further raise the bar for alternative theories. So if there is more data and there are still models that can account for this, but that would increase the strength of the conclusion that probably it's getting more and more difficult for other approaches to explain everything that has been explained, even though that data is not stringent enough yet at all to single out one model, saying within the inflationary paradigm, that's the true model. So on that basis, evidence can significantly increase trust in the theory. So that's the basic idea. And very briefly, I think, how much time do I have? 5 minutes. Okay. So very briefly, I think one can make the claim that NAA, alternatives argument, and the support parameter inductive argument, they can be used in this context. It's clear that there is this understanding among inflationary cosmologists that there are no other ways, and then inflationary cosmologists often argue against alternative approaches and justifying that basis why they have trust in inflation. Here once again, quotations from Linda that expresses this. Of course, one must say that what is implicit here is the meta-empirical step, right? But it's clear that you need that. So explicitly, this is talking about known alternatives. No one has found an alternative. But it's only significant, only relevant for credence if you infer from that actually the fact that we haven't found any, to me suggests that probably there aren't any. If there was no connection between the two, this would be entirely irrelevant. And so one needs some support by something like MIA or empirical assessment or unexpected explanation. And normally one would argue that in these contexts, meta-empirical assessment is motivated quite generally based on success stories in high energy physics or success stories in the context of general relativity, things of that kind. So that would suggest, or that would provide a basis for saying there is a tendency in well-developed theoretical physics to be able to scan the options. So if one finds one option and one doesn't find others that seem promising, there is a certain plausibility or probability that that's actually the only option there is at that level of description in the given domain. That doesn't mean that it's final theory, but in the given domain, that would be the case. So that's what would be needed. When it comes to unexpected explanation is weak and shaky in this context for the very reason INS pointed, right? So it's not clear. In order to have strong unexpected explanation in this context, you would need some very strong novel confirmation argument. You would say there is a very specific prediction from inflation, and this very specific prediction was not thought of when developing the theory, and here you go. That's exactly what we find. And there, to some extent, one might say, well, here you go, generic models are in agreement with that. So it's not the case that it's absent, but it's not particularly strong. It's weaker, arguably, than any other context. One interesting, though, for also controversial case is anthropic reasoning, where you might say, to the extent that you have you take anthropic reasoning to give a certain prediction, to predict that the cosmological constant is roughly where it was discovered, that clearly is a null prediction, a successful null prediction. So having said all this, none of this. I don't want to suggest on that basis that this, as I presented it, establishes that there is a strong case of MEA case for inflation. I think that's clearly not the philosopher's task to do that. That is something that is a matter of the physicists' deliberation on the subject. All I want to introduce here is that to the extent there is credence in inflation, I suggest that that's the basis for it. That is the way the mechanism works. Okay, which brings me to the conclusion. The point was, or what I tried to argue was, that credence in inflation depends on empirical assessment, and it can be argued for on that basis. On the other hand, viewed in terms of a simple notion of empirical confirmation, credence cannot be argued for. And that is the way what INS are pointing at in their argument, if you turn it probabilistic, let's say. And this is not qualitatively different at all from any other theory. That's generally the case. But the peculiar relation between models and theory at the current state of inflation makes this point much more conspicuous. And therefore, I think it's a very nice example for making it. Thank you.